do we have a sense of if we implement X today, it will begin to slow the rate of increase of warming by Y next year or 5 years or 7 years or 10 years out?
Yeah, so we can make those sorts of projections. We use models that have been vetted fairly well. They have been validated in terms of the predictions they make and how those match up with observations. And so we do have climate models and models of the carbon cycle that allow us to look at implications for different fossil fuel burning, different scenarios of fossil fuel burning into the future, what implications that has for climate. And it is sort of like a cloudy forecast. It's not a precise forecast because there's uncertainty. There are physical uncertainties in each step of that process. And so we can provide a range. And so what scientists do is they take that range of possible impacts, that range of projected warming, given a certain pathway of human behavior in the future, and they can look at it in a probabilistic sense, asking questions like, how much do we have to reduce our emissions to have a greater than 50% chance of avoiding, say, that 2 degrees Celsius threshold? And so often what scientists will do is they'll take into account that uncertainty by framing it in that probabilistic sense. What do we need to do to have a 2/3, a 67% chance of avoiding that amount of warming? And so you can see, given the uncertainty, that some of the questions we ask are framed with a certain level of risk averseness. How risk averse are we? Is 50% good enough? Is 67% good enough? Do we want to be certain at the 90% level that we will avoid 2 degrees Celsius warming? Well, if we want that level of certainty, then the reductions have to be even greater.